Hello everybody, I'm Sri Hartini from Universitas Indonesia, and here I want to present our research entitled Estimating Probability of Banking Crisis Using Random Forest. This presentation is doing for 2020 First Conference on Internet of Things and Embedded Intelligence. So this is my outline of presentation. First, I would like to give an introduction and then we will discuss about the data. After that, we will talk about our proposed method that is random forest and how we examine its performance through performance measurements. And at the end, we will discuss the results and analysis and also the conclusion. Banking crises are costly to the economic crisis not only because of high direct cost saving, but also because of adverse effects on the economy. Crises in banks can significantly lessen the global economic growth by slowing down economic activities, limiting the number of stable currencies for emerging economies, and weighing on their capacity to pay their debts. Banking stability itself continues to receive heightened attention since the global financial crisis in 2008. So here we try to estimate the probability of the banking crisis. Statistical method is a standard approach to estimate the probability of banking crisis, but low accuracy has been obtained by some standpoints of statistical techniques. And the disadvantage of statistical method is we should follow the assumption of each method. If the data is not fitted to the assumption, we cannot use the method. Then, by the development of computational method, one of the methods to prevent banking crisis that researchers usually use is machine learning. As the one of techniques in machine learning, random forests often make accurate and robust prediction even for very high dimensional problem, with the subsampling that plays an important role in random forests so that it needs to be tuned more carefully than other parameters. Random forest was used before by Rustam and Saragi in predicting bank financial failures using CAMELS, which is an international rating system used by regulatory banking authorities to rate financial institutions and succeed to deliver 100% of accuracy. Therefore, in this research, the random forest was proposed not only for the classification but also for the regression to predict and estimate the probability of banking crisis. And about the data, in this research we utilized the financial crisis database formed by a sample of 79 countries in the period 1981 to 1999, which is an annual data, and this database has 521 samples consisting of 164 crisis samples and 357 non-crisis cases. These 11 features describe each sample, which labeled as the crisis or not. The target clause equals 1 if the bank crisis happens and equals 0 if the bank is not in a crisis condition. And then as the proposed method, we used the random forest, which was first introduced by Brayman. Random forests are a type of ensemble technique that makes prediction by averaging over the prediction of several independent base models. The algorithm of random forest is already given in this slide. So given a training set with n observations and n features, we want to build our trees. For every tree, first we draw a bootstrap set with n observations from the training set. Then we build a decision tree. Then we fully grow each decision tree without pruning. And at the end, we will get the assembled decision tree, which is random forest. Now, the random forest has already built. When classifying the input samples, the results depend on the majority vote from the output of each decision tree. For the regression purpose in determining the probability of banking crisis in this research, the number of predictions of each class divided by the number of trays. Then our proposed method will be evaluated using the conversion matrix. According to this table, CITEI is the number of crisis bank samples which were correctly predicted. FP is the total of non-crisis bank samples which were incorrectly predicted. TN is the count of non-crisis bank samples which were correctly predicted. And Fn is the number of crisis bank samples which were incorrectly predicted. An evaluation was then carried out according to the conversion matrix to calculate the accuracy, sensitivity, precision, and F1 score to determine whether the method proposed can be used for estimating the probability of bank crisis. As explained before, the performance of random forest in classifying whether a bank will be in crisis condition or not will be evaluated according to its accuracy, sensitivity, precision, and F1 score. Its performance was given in Table 1. From this table, we can conclude that the average of each aspect of performance measurement is 0.96 accuracy, 0.89 specificity, 0.88 precision, and 0.88 F1 score. Besides, the performance when using 90% of training data is better than when using other percentage with 0.98 accuracy, 0.92 specificity, a perfect precision, and 0.96 F1 score. Therefore, assume we use the model built using 90% of training data. If we were given 100 banks to be predicted, there is a 98% probability that we will predict it correctly. For the crisis bank cases, there is a 92% probability that we will correctly predict the crisis bank among all of the crisis banks that we predicted. And there is a 100% probability that we will correctly predict among the banks that actually crisis. Furthermore, the conversion metric for the performance of training and testing set in a random forest model was given in Table 2 and 3, respectively. Both from those tables, the number of non-crisis banks is higher than the number of crisis banks. Furthermore, from Table 2, it shows that there is no sample that incorrectly predicted both for the crisis bank and non-crisis bank. Meanwhile, Table 3 shows that there is a crisis bank that was incorrectly predicted as the non-crisis bank in the testing set. For more detailed view, Table 4 shows the probability of each class prediction. If the probability that it is a crisis bank is greater than the probability that it is a non-crisis bank, then the sample concluded as a crisis bank. As an example, a sample number 5 in Table 4 has a 0.97 probability that it is a crisis bank and has a 0.03 probability that it is a non-crisis bank. Then the sample number 5 was predicted as the crisis bank. The same rule was also applied to other samples. For sample number 50, it has 0.51 probability that it is a non-crisis bank, which is higher than 0.49. Therefore, the prediction class for the sample is a non-crisis bank, which is a false prediction according to its actual class. So, for the final statements, here are some summary and conclusion according to my previous explanation. So from the experiments, the accuracy of our proposed method succeeds in providing up to 90% accuracy, sensitivity, precision, and F1 score. Therefore, it can be concluded that the random forest can predict the probability of crisis or non-crisis banks accurately. And as the future work, an updated dataset can be utilized to analyze our proposed method for obtaining new insights, and also other methods, especially the assemble method, are also recommended to be developed. And here are our references. And thank you for listening to my presentation.